on your screen. The probability of getting 7 on throwing a dice is 0. The sun rises in the east. X plus y equal to 12. Rectangle has 3 lines of symmetry. India is the best cricket team in the world. Where do you live? Mumbai is capital of India. If you look at all these sentences which we come across in our daily life, have you ever checked the truthfulness of these sentences? So, children, today in our topic, that is proofs in mathematics part 1, we are going to learn more about these. By the end of this session, you will learn statements, mathematical statements, verifying the statements, and also reasoning in mathematics. So, let us first start with the statements part. So, children, you can notice some sentences that we have already discussed in our first screen, isn't it? Now, consider the sentence rectangle has 3 lines of symmetry. Children, do you agree with this sentence, that is a rectangle has 3 lines of symmetry? No. We have already learnt in our previous classes that a rectangle has only 2 lines of symmetry. So, can I say it is a false sentence? Yes. Mumbai is capital of India. Now, what about this sentence, children? This is also false, because we have learnt or we know that Mumbai is capital of Maharashtra, which is one of the state of our country India. Have a look at another sentence, x plus y is equal to 12. Now, children, do you think this is true for all the values of x and y? No, but I can say x plus y is equal to 12 is true only for some cases. That means, if I take x is equal to 0 and y is equal to 12, then this is true. Apart from that, if I take x equal to 1, y equal to 11, then also it is true. So, like this I can substitute few values of x and y, only in that case this sentence is true, that is x plus y is equal to 12 is true, not for all the values. Now, have a look at this sentence, that is 2p is equal to 5. Now, is it true? Yes, it is also true, but only for one particular case, that is the value of p is 5 by 2. Apart from that, you substitute any value, this is not true. So, that means, if you see these two mathematical sentences, I can say they are true only on certain conditions, they are not totally true. Now, have a look at some other sentences, that is the sun rises in the east. Now, what about this sentence, children? Yes, it is absolutely true, right? Sun always rises in the east. Now, take a look at this sentence, children, that is the probability of getting 7 on throwing a dice is 0. Now, is this sentence true, children? Yes, again this is true. Why this is true, children? Because in a dice, if you notice, we have only 6 numbers, 1, 2, 3, 4, 5 and 6. Now, there is no question of having a 7 on the dice. Now, how many times if you throw also, you never get 7. That means, the sentence which is given is absolutely true for every case. So, children, we have seen certain cases where the sentences are true and some sentences are false. So, here if you notice, the probability of getting 7 on throwing a dice is 0 is always true, and the sun rises in the east is also true, whereas rectangle has 3 lines of symmetry or Mumbai is capital of India is always false. Now, such type of sentences we call them as statements. So, children, what is the statement then? The sentence that can be judged on some criteria, no matter by what process, for them being true or false, are called statements. That means, a sentence should be either true or false, then only we can say it is a statement. Now, let us consider some more sentences, that is this sentence has some words. So, this is the sentence actually, and I will take another sentence, you may find life on Mars. Now, these are the two sentences. Have a look at the first sentence, children. What actually it conveys? Yes, it states that the sentence is talking about itself only, right. It is having some words. Now, whereas if you consider the second sentence, you may find life on Mars. Now, what does it convey, children? Yes. So, this sentence have words that show only likely or possibility. That means what? There may be life or there may not be life on Mars. Hence, we see some ambiguity in this statement, isn't it, children? So, we define the sentences which are talking about themselves, and the sentences with possibility are not statements. That means, here these two statements, that is, this sentence has some words and you may find life on Mars, they are not statements, because they talk about themselves or there is some ambiguity in this sentence. Now, let us learn about mathematical statements. Now, consider the following sentences. I am going to tabulate as shown on your screen. 2 is a prime number. Now, is it a mathematical statement or not? Yes, absolutely it is a mathematical statement. Now, whereas if we consider Ramu is a good boy, is it a mathematical statement? No, it is not related to mathematics. Now, product of two odd integers is even. Yes, it is a mathematical statement. For any real number x, 3x is greater than x, even this is also a mathematical statement. Now, let us see the final sentence, that is Bhaskara wrote Bija Ganita book. Now, is it a mathematical statement, children? No, even this is also not a mathematical statement. So, the sentence which can be judged either true or false, but cannot be both, are called statements. So, children, you understood now what is exactly a statement is. The sentence should be, it should be true or it can be false also, but it cannot be both. Such type of sentences we call them as statements. So, children, we have learnt about statement. Not only that, we have identified mathematical statement also. Now, we will learn more about verifying the statements. Let us consider an example, children, that is 2 is a prime number, just now we have seen in the previous case. Now, children, can you recall what a prime number is? Yes, we can say that a number is prime if it has only two factors, that is 1 and the number itself. Such type of numbers we generally call it as a prime number. Now, here 2 is also a prime number. Why? Because it has only two factors, that is 1 and 2 itself. Now, the statement that is 2 is a prime number is absolutely true. Now, let us move on to our next example, that is Ramu is a good boy. Now, what is the truthfulness of this sentence, children? Is it true? We cannot say, because this sentence is very much ambiguous. Why? Good means it may be good to me, but may not be good to you. That means we cannot directly say, we cannot generalize it. Ramu may be a good boy according to me, but according to somebody else, he may not be good, right? So, always there is some ambiguous sentence, this one. So, we therefore recognize that a mathematical statement, or in fact any statement, must comprise of terms that are understood in the same way by everyone. Suppose if I say 2 is a prime number, it is a prime number, let it be any person, whoever it might be, they will accept it as a prime number. Got it, children? Now, let us take one more example, that is the product of two odd integers is even. So, let us consider two integers, children, that is odd integers 5 and 7. Now, what is the product of 5 and 7? 5 into 7, which is equal to 35. Now, what about this number 35, children? Yes, it is an odd number. But children, if we have taken, what is the statement here? Product of two odd integers is even, but when I calculated the product of two odd numbers, I got it as an odd number. Then what can you say about this statement? Yes, I can say it is a false statement. So, here we are able to verify the statement using an example, isn't it, children? So, this is a statement given, we have taken an example by taking some integers, right, or the odd integers, and we have proved that the given statement is false. Now, such type of statements or such an example here that counters a statement is called a counter example. So, I can say this is a counter example way of disproving a statement. Let us move on to our next example. Bhaskara wrote Bijaganita book. Now, children, how would we verify this to consider it as a statement? Now, for this, first check, here it is not ambiguous, but we need to test this, that is whether it is written by Bhaskara or not. Not only that, we need to require some observations or evidences showing that Bijaganita was written by Bhaskara. Got it, children? This is how we verify the statements. So, children, we have learned about mathematical statements and verifying the statements. Now, let us see or let us learn about reasoning in mathematics. Now, generally all the human beings are very much curious to learn some new things. For example, they always think about what happens if we push this particular thing. Not only that, what happens if we stuck our finger in that? Apart from that, what happens if we make various gestures or expressions? Now, when we have such questions only, this curiosity is actually which makes us learn more and more new things. So, while doing this, we think what happens, and by doing experiments or observations, we lead it to yes, this will happen if we do these things. So, this is how we reason it, right, children? If we do this, what will happen? But after experimenting or observations, then definitely you will come up with an answer that if you are going to do this, something is going to happen. So, children, now let us see the pattern for the concept of making and testing the hypothesis. So, for that, the most important thing is make some observations, collect data based on the observations collected. Okay, children. Then draw conclusions which will explain the pattern of the observations. Then you need to test out the hypothesis by making some more targeted observations. So, children, here hypothesis is a statement or idea which gives an explanation to a series of observations. So, let us take an example, children, to understand this deductive reasoning. So, the main logical tool used in establishing the truth of an unambiguous statement is deductive reasoning. So, let us solve a puzzle, children, using deductive reasoning. So, there are 4 cards given to us, and each card has a number printed on one side and a letter, that is an alphabet, on the other side. Now, let us see the condition. If a card has an odd number on one side, then it has a vowel on the other side. So, this is the condition given to us. Then what is actually we need to do here? Yes, what is the smallest number of cards you need to turn over to check if the rule is true or not. That means, there are 4 cards. I can turn all these 4 cards, but I need to turn minimum number of cards, maybe 1 card or maybe 2 or maybe 3 also. Okay. And see that this rule or this condition is satisfied. So, let us solve this puzzle, children. So, first carefully read the condition, that is, if a card has an odd number on one side, then it has a vowel on the other side. So, what do you mean by this, children? Yes, it does not state that a card with a vowel on one side must have an odd number on the other side. So, if it has an odd number, then other side should be a vowel. But suppose if it has a vowel on the other side, it need not have an odd number or something else. Okay, children. Now, not only that, even we can say that the rule does not state that a card with an even number on one side must have a consonant on the other side. So, using these, we will solve the puzzle. So, for the first, let us check, do we need to turn over this A, that this card we need to turn it or not? No. Why we do not need to turn this card? Because if you see A is a vowel. So, when you turn this vowel, we have already seen on the other side there should be a number, but it can be any number, because it states that an odd number on one side should have an vowel, but if there is an even number or odd number on the other side, the rule still holds good. So, we do not have to turn card A. So, children, do we need to roll this card having number 8? Let us see. So, if you notice, we do not have to roll over this card with number 8 also. Again, what is the reason, children? Yes, since it is an even number, whether there is an vowel or a consonant on the other side, the rule still holds good. So, children, do we need to turn over V also? Let us see. Yes, in this case also we need to roll or we need to turn this V. Now, let us see why we need to turn this V, because V is actually a consonant, right, children. Now, if there is an odd number on the other side, the rule will be broken, because whenever there is an odd number on the other side, definitely there should be a vowel, but here if you consider this V, V is a consonant. So, we need to turn this card V. Now, we are left with only the last card, that is 5. Now, children, do we need to turn this card also? Yes. Why again? So, as per the statement, if you notice here 5 is an odd number. Now, when you turn on the odd number, the other side there should be a vowel. So, if you turn this card 5, definitely there should be vowel. Instead of vowel, if there is a consonant, that means the rule will be broken. So, what can we say, children, here? Out of these 4 cards, we need to just turn on these 2 cards, that is V and 5, to solve this puzzle. So, this kind of reasoning we have used to solve this puzzle, we call it as deductive reasoning. That is, why we call it as deductive reasoning, children? Because we arrive at, or we are going to deduce or infer a result or a statement from previously established statement using some logic. So, that is why this is called as a deductive reasoning. So, deductive reasoning also helps us to conclude that a particular statement is true because it is special case of a more general statement that is known to be true. So, let us understand this statement with an example, children. So, if we have already proved that the product of 2 even numbers is always an even number, now what about this number, children? That is the product of these 2 numbers shown on your screen. Yes, the product is also an even number. But how can you say the product is even? If you notice, the first number is an even number, the second one is also an even number. When I am multiplying these 2 according to this previously established statement, I can say the product of 2 even numbers is also an even number. So, this is the advantage of a deductive reasoning, children. So, children, till now we have learnt about mathematical statements, verifying the statements, and also we have seen reasoning in mathematics. In that we have seen about deductive reasoning and solved a puzzle also. So, children, let us apply the concepts that we have learnt in solving few examples. Let us start with a first example, children. State whether the following sentences are always true, always false, or ambiguous, justifying your answer. First sentence is, square numbers can be written as the sum of 2 odd numbers. There are 27 days in a month. For any real number x, x square is greater than or equal to 0. Independence Day falls on Saturday. Let us start with the first sentence, children. So, square numbers can be written as the sum of 2 odd numbers. So, children, can you recall the square numbers? Yes, 1, 4, 9, 16, so on, these are called as square numbers because they can be written as product of 2 equal factors. So, if you consider the first square number 1, you cannot write it as sum of 2 odd numbers. So, 1 can be written as maximum 0 plus 1, right, and 0 is not an odd number. So, 1 cannot be written as sum of 2 odd numbers. Hence, the given statement I can write it as a false statement. That is, square numbers can be written as the sum of two odd numbers is false. Let us move on to our next sentence. There are 27 days in a month. So, children, we generally have either 30 days or 31 days in a month, but if you notice February, we have only 28 days or 29 days depending on the leap year, isn't it, children? That means what? Each and every month will have a minimum of 27 days, not just 27 days, isn't it? What do you say about this sentence, children? Yes, again the given sentence that there are 27 days in a month is also false. Let us move on to our next sentence, that is, for any real number x, x square is always greater than or equal to 0. So, let us consider the values for x, children. I have taken x equal to minus 2. So, minus 2 whole square is 4, and I have taken x equal to 0. You got 0 square as 0 again, 5 square as 25. So, in all these cases, if you notice, we got 4, 0 and 25, which means it is always greater than 0. Hence, I can say that on substituting x value as any real number in x square, we always get a number which is either greater than or equal to 0. Hence, I can say that the given sentence for any real number x, x square is greater than or equal to 0 is always true. Let us move on to our next sentence. Independence Day falls on Saturday. So, in maybe 1 year or maybe in some years, maybe it falls on a Saturday, but it is not necessary that it will always fall on Saturday. That means, the given sentence is an ambiguous sentence, because it may fall or it may not fall. Okay, children. So, that is why we say it is an ambiguous sentence. So, let us move on to our next problem, children, that is disprove by finding a suitable counter example for the statement x square greater than y square for all x greater than y. Let us start with the solution. So, what you are going to do is we are going to substitute x equal to minus 1 and y equal to minus 2, because here x is greater than y, because minus 1 is always greater than minus 2. Now, let us find the values of x square and y square, children. Y square is equal to minus 2 whole square. So, what do you get? Minus 1 whole square as 1, means x square is 1, minus 2 whole square is 4. So, y square is equal to 4. Now, if you compare these two, I can say 1 is less than 4, but what is 1, children, here? X square, and what is 4? Y square. So, I can conclude that x square is less than y square. But, children, if you notice, here we got x square less than y square, but what is given to us? X square is greater than y square. So, that means what? Here the given statement is disproved, right. So, we have given a counter example. We have taken an example and proved that the given statement is false. Okay, children. So, children, let us move on to our next problem. Restate the following statements with appropriate conditions so that they become true statements. So, for every real number x, 3x is greater than x. If a quadrilateral has its side equal, then it is a square. If you divide a number by 2, you will always get half of that number. Let us start with the solution. So, for every real number x, 3x greater than x. So, for this, the condition is if x is greater than 0. So, it is true only when x is greater than 0. If x value is less than 0, the given statement would be true. So, this is the condition, children. The next one is if a quadrilateral has all its sides equal, then it is a square. But, children, we have already learned that if all sides are equal, then it is also called as what? A rhombus. So, that means if a quadrilateral has all its sides and interior angles equal, then only it is called a square. Now, the third one, if you divide a number by 2, you will always get half of that number. So, you take any number, children, if you divide by 2, definitely you will get half of it except 0. So, the condition is if you divide a number other than 0 by 2, then you will always get half of that number. Let us move on to our next problem. So, again here you are given 4 cards, each card has a number printed on one side and a letter on the other side. Now, which are the only 2 cards you need to turn over to check whether the following rule holds or not. So, if a card has a consonant on one side, then it has an odd number on the other side, and these are the 4 cards given to us. Let us start with the solution. So, if a card has a consonant on one side, then it has an odd number on the other side. So, what do you conclude, children, from this? Yes, the rule does not state that a card with odd number on one side must have a vowel or consonant on the other side. Apart from that, it does not state that a card with a vowel on one side must have an odd number or even number on the other side. So, let us solve the puzzle, children. So, do we need to turn over 3? No, absolutely we are not going to turn over 3, because here 3 is an odd number, right. If there is an vowel or a consonant on the other side, the rule still holds good. So, let us go for the next one, that is U. Now, do we need to turn this U also? No. Why again? If you see, U is a vowel. So, if there is an odd number or even number on the other side, again the rule still holds good. So, that means we will go for the next one, that is B. So, is this B, we are going to turn over B? Yes. If B is a consonant, it should have an odd number on back side. Got it, children? Now, let us see, can we turn over 8 or not? So, if we turn over 8, we need to turn over 8 also, because 8 is not an odd number, I can say it is an even number. So, it should have a vowel on the back side, it should not have a consonant according to the given rule. So, hence I can say that we can only turn on 2 cards, is not it, children? So, children, till now we have learnt about mathematical statements, verifying the statements, and also reasoning in mathematics, and solved few examples. Now, before we conclude, let us quickly recap what we have learnt in this session. The sentences which can be judged either true or false, but not both, are called statements. A hypothesis is a statement or idea which gives an explanation to a series of observations. Mathematics is based on deductive reasoning, and a proof is logically deduced from a set of clear inputs, whereas science is based on inductive reasoning. Hypotheses are strengthened or rejected based on accumulation of experimental evidences. The main logical tool used in establishing the truth of an unambiguous statement is deductive reasoning. So, children, I would like to give you some assignment which are based on the concept that we have just learnt, and please do work out these problems and show to your subject teacher. Restate the following statements with appropriate conditions so that they become true statements. So, for any x, 4x plus 1 is greater than 5, and the second one is 3 times a real number is always odd. The second question is, disprove by finding a suitable counter example the statement x cube minus y cube is greater than 0 for all x greater than y. The third problem is, state whether the following statements are true or false, and also give reasons for your answer. The first is, the sum of the interior angles of a triangle is 200 degrees. A rhombus is a square. Let us move on to a final question. Use deductive reasoning to answer, if a number ends in 0, it is divisible by 5. 30 ends in 0. Now, based on the above statements, what do you conclude? So, children, with this we come to the end of our session. I hope you have learnt all the concepts clearly, and I want you to submit the assignment given to your teacher also. So, we will meet you in our next digital class. Until then, goodbye and take care.